joining. Thanks for coming. Dynamic Media Factory, what is it really about? I want to talk a bit about how to harmonize ICT and media workflows and operations. Because when we look into what's going on in the media landscape, media is becoming IT and much more software than it ever was before. But not like a regular domain in that overall ICT software space, much more a very specific thing you see with sharing some general concepts from IT, from ICT, but also have its own specifics in media, which is not part of every IT solution out there. And when we look into existing media customers, we are all good in managing live services, real-time operations. We know about how to control things in real time, how to manage time and sync our media assets. And we run, that's important, a lot on tailor-made broadcast-specific platforms, which are usually too big complex. When we look into the ICT concepts, and that's, I guess, where everybody, most of our customers agree, there are other concepts out there. And this is also where a lot of broadcasters, media companies are lacking. In ICT, we talk more about data-driven operations, applying DevOps concepts. You have CI/CD, continuous integration, continuous deployment possibilities and concepts out there. We talk about continuous evolution. Security is a big topic in ICT that we don't take very serious or that serious in media yet. Managing changes, everything is much faster. That's all coming from ICT, where we typically lack a bit in media operations or in media companies. And the tools, when you look into those in IT or used in ICT, those are much more mainstream tools, generalized tools. But all those tools we cannot really use out of the box. And what we call media ops here, that new frontier, that's really to convert and to converge ICT and media operations into something that we can use in broadcast. When we look into the requirements of a dynamic media factory, as we call it here, when you look into it to manage everything you do in an MCR, in playout, in contribution, in distribution, everything has kind of a life cycle. And throughout that life cycle, multiple teams are involved. And that starts with teams in the facility, building your infrastructure. You have your customers, you have booking teams, scheduling teams. On the other end, you have procurement teams to send and create the bills. And in the middle, where we are more familiar with broadcasting teams, also IT, ICT teams, MCR, playout, then they need to work together in one way or another. They cannot operate, as we see it often today, in isolated environments anymore. Another big part is when we look into the requirements to make things dynamic, we need to integrate with a lot of third-party infrastructure and systems. And I'm not only talking about hardware infrastructure, media infrastructure on and off-prem. A lot more we talk here about databases, IPAM systems for IP address management, CMDBs for infrastructure management, ticketing systems, you have planned maintenance systems. That all needs to go together with the media infrastructure, like your classic routers, broadcast controllers, SDN controllers. And whenever you want to make things more dynamic and you want to build that dynamic media factory, you need to have a way to interface also with those non-media systems, all the databases around. Another important aspect, a third one I want to bring up here, it's about digitizing workflows. When we talk about a lot of people working together, integrating with a lot of different systems, it's not that you hand over data from one team to another via a piece of paper. You need to digitize workflows, and digitizing workflows starts or has many, many aspects. And I want to give a few ideas and share some ideas. It starts with onboarding inventory. Inventory onboarding, we just heard about it, can be via NMOS. ISO 4, it's an inventory onboarding mechanism, but can also be an external database, a CMDB database a lot of big customers are running. You need to create what we call bookable resources. When you want to manage things in the life cycle, you need to know which resource can I book. And that can be encoders, decoders, all my infrastructure, but you need to build that. Those are both physical and virtual resources. Virtual ones can be people, trucks, rooms, everything you do not control at the end or don't automate, but you have to be able to book those as well. You have to define your inputs and outputs. In SDI, that was simple. An input was equally the same as an a BNC connector. Now in IP, it's different. What is an input? What is an output? In 2110, as we have heard it, this is not only one stream, those are always multiple streams. You need to manage your IP addresses. And then you go into planning and reserving. When you look into any kind of workflow you do, a simple workflow could be like a satellite downlink, a fiber contribution, setting up an OTT channel. That's also a workflow. You need to plan resources to manage your work orders, events, productions, setting up a complete studio production in a more dynamic environment. But also think about the non-media related planning things, planned maintenance. If you have to do an update in your switch infrastructure, what are you doing? That's another event you need to manage. Software updates. And all of that somehow requires reserving resources, typically from resource pools. Again, my online, offline resources. But also you need to reserve capacity and bandwidth, not only the resources as such. And once you have done that, and we go into that green part, when we look into life cycle management, nowadays, a lot of equipment doesn't exist at the time when you book it. When you think about a cloud resource, you need to deploy it maybe a week later, a day later, right before the event starts. You might have to reprogram FPGAs. You have to spin up a virtual machine, manage your microservices. So that deployment part of a life cycle of anything you do, a few years back didn't exist, becomes much more important than ever before. Then things we know, configuration, pre-configure your vision mixer, your encoders, decoders, video servers, connect them together, as we all know, via IP, SDI, but also think about VLAN management, netting to bridge one network to another one. And where we are usually most familiar with is really the control monitoring part, connection management, parameter control. Monitor all your infrastructure, your services, your SLAs, virtual machines, microservices. And at the very end of a event, also important, don't forget about that, you need to undeploy your resources again. Cloud resources, you need to stop them, otherwise you pay forever. You need to put them back into a safe state, disconnect them. And then what is that really about? When we run a media operation, you need to track your costs, infrastructure, create the billing records, the internal costs. And all of that you somehow want to automate the best way you can do. Automating means digitizing workflows. Something I want to bring up, what is the difference between automation and orchestration? Automation is not the same as orchestration. Orchestration is more than automation, more than controlling, scheduling. Orchestration is often what people think IP signal switching, but it's also more than that. Orchestration, as we define it, is a framework to automate the life cycle of an event and a service end-to-end across multiple domains, multiple technologies, and very important here, to manage and track the resources over time. Keep in mind the availability, capabilities, capacity, and only then we call it orchestration and not automation anymore. So that time awareness is a very important factor when we talk orchestration. A fourth aspect I want to bring up to make a media facility more dynamic, it's about user interfaces. Nowadays, we talk much more about easy-to-use UIs, personalized UIs, desk-aware user interfaces. When I walk in, I log in with my name. I want to see the exact user interface I expect, the right multi-viewer configuration. I have a certain preference, but also schedule-aware and task-oriented. The user interface somehow needs to follow what you want to do. In an ideal case, the UI only shows you what you need to operate and doesn't give you the options to break anything different. But not that you have to rebuild all those user interfaces all the time. That's important. We always say reuse and integrate with existing UIs wherever appropriate and wherever useful. And before you start, because we see a lot of projects, kind of saying failing, but being challenged when people want to automate everything you can ever automate, we always say question every requirement up front. Then delete the parts and the processes you don't necessarily need. Start with the simple things. Simplify, optimize, accelerate, then speed up, become agile, and only then automate. And you might have seen that before. That's not coming from us. That's what the people call the Elon Musk algorithm. This is how he runs all his companies. But I think it was a good example where we can really compare that against what we want to achieve in media operations. Being data-driven, simplify and automate. But don't start with automation first. Think about what you, what you need first. And then let's have a look a bit, how can we build that? Looking into an architecture, what we think you need a modular stack to build that, because you can only go step by step. You cannot do everything in one day. And that modular architecture needs a data collection and control plane, as we say, that allows you to interface with all the infrastructure. This is mandatory, otherwise you don't even need to start. And then we call it what we call a digital twin. This is really a copy of everything you have, everything you run, all your infrastructure in the cloud or on-prem, all your data sources that you can work with. And then on top, you see the data consumption. Data consumption is for users, user interfaces. Remember, the right user interface for the right people at the right time, but also about in between. Then it's not only that you want to consume data as a user, you also want to be able to do something with the data, and that's the automation part, the orchestration part. Add all the logic, what to do with the data you have to present the right data to the right people. And data consumption, to wrap this up here, is not only about providing user interfaces, but also, again, providing APIs to other systems. If I need to hand over the costing and billing information, that's not something you do via a user interface. That's typically an API call, maybe to your billing system. And to build something, that allows you to manage that dynamic media factory, such platform needs to give you the chance or the possibility to pick and choose the functions you need when you need them and to adapt to your need. It's not that you can build this in a single day. How do you do that? You need to deliver value fast at the beginning. You don't want to build something for a year and then do the first iteration. It's about that it supports agile methodologies, that such platform supports a DevOps approach. And when we look a bit deeper, I talked about that digital twin. What is that really about? Here is one example, what we call a digital twin. You might have a metric. A lot of systems, they support metrics. Here is an example of an RX bitrate. A metric has a unit, a min value, a max value, step size, has historical information, which is super important, because only with that you can make the right decisions then. That metric, we probably know, there was a firmware update done, it was in a certain service, travels from one service to another service, has a history of alarms, the active and historical alarms. And all of that information needs to be somehow stored in a database to do the right things with your infrastructure data. And when we look into data you need in such a stack, it's not only that you get metrics from infrastructure, but also we talk a lot about administrative data. Administrative data is to manage the life cycle again of your work orders. You need a start date, a stop date, you give it a name, you have any other admin non-technical data, and you need to store them somewhere. And you need what we say a common data model. Build that data model, have a central repository, a single source of truth, as we say, store all the data in one big data model, in one big database. And only that allows you then to show the right data to the people when the data is required to manage the business and operational data. What is super important about that data model, it needs to be state aware. Those data models we are working with, we call it, they have stateful objects. What is a stateful object? When you look into a life cycle, again, maybe a job state. A job is not something that starts and stops and that is it. It has multiple phases. Again, throughout the life cycle, you start with the booking team. They might only enter a start and a stop date. You hand it over to the MCR team. They have to enter more data over time. You hand it over to the next team, to the playout team. They might add more data, or they only want to see a subset of the data. So that data is used to travel through the life cycle of your media operations, and it needs states. And in that example, we have states like it's in draft, it's running, it's completed, it has been invoiced. What we call here stateful object for a job, as an example. Another example can be people. When you have people, everything has a state. A person can be in onboarding. he just started, but I can't use him yet because he still learns. Or he's off sick, that's also a state. A resource, the same thing. A resource is not just there and not there. A resource can be ready in draft, still in planning, in onboarding, can be broken, deprecated, or it's back on the shelf, I can't use it. So everything you do in those, when we work with data, should be stateful in our eyes. That's why we call it a stateful object model, that common data model. Next to the data we gather, remember we talked about the user interfaces, dynamic ones. How do you build those? The best person who knows what we always say, what needs to be on a user interface is the user itself. The users are usually not developers, which is a problem because they cannot build their own apps then. There is the approach of low-code applications to really allow people with no or only low experience on how to develop things. You don't have to be a developer for that, to build their own user interface. That's the low-code approach. Here are a couple of examples from our customers that operators have built on their own, teams with no coding experience have built. The idea is always to build apps fast and easy, and to build many different applications, many different user interfaces, because you have different teams with different needs. It's not sufficient anymore to build a single UI that does the job for everybody. When you have an IT person in a network, he has a different angle looking into a network than a media person who is probably only interested in certain multicasts. But the IT person needs much more information to make the right decisions on the network, what to do next. How do you operate? This couple of screenshots from one of our systems. What does it mean when we talk low-code applications? It's really a graphical editor. If you have the rights, you can go into an edit mode. You have your widgets. On the right-hand side here, we have the real-time data in that example, which is our digital twin. And then you just drag and drop things together, the data together with a widget, how to visualize things. In that case, that's a routing panel. You fine-tune the layout, you publish it again, you operate. If you don't like it, you edit again, you create another version, or you go back. The whole idea of being agile also comes with those low-code applications that you can improve them and evolve over time. Next to applications, next to low-code applications, you still certainly need to do some coding at some point in time. And there we talk about continuous evolution and CI/CD platforms, continuous integration, continuous deployment. What you need there is you have to have your own code repository. It's not enough that you have one developer building his single automation script and puts it on air. You need to put it and live those ICT principles, and CI/CD is essential to evolve over time. CI/CD means somebody creates something, a next iteration, puts it in his code repository, creates what they call an artifact. This is all API driven. Then you put it on staging, you try things out. If things are working well, you put it in production. What you see here, that's all automated. You cannot do and evolve over time when you do this in a manual way. This is why you have those CI/CD platforms. And only then, when you automate testing, this is what you actually do, you can evolve over time. And be sure that you don't break things in production. And a few examples on how those low-code applications look like for different people in different parts of the organization. We were working on a solution, we call it dataminer.mediaops. Dataminer is our product, our framework. We have worked on an off-the-shelf solution for our customers to allow different people doing the right things with different toolings. And that starts with, for example, inventory management. There we talk about managing resources, managing resource pools. And what's also important when we talk about resources is not only a resource that you use or don't use. Resources, they have properties like an availability. A resource is available or is not available. That's something you need to track in the database to make sure you don't overbook the resource. But more important, resources also need to have and support capabilities. Simple example is my resource supports SD, HD, UHD. That's a capability. Knowing that, I can make the right decisions when I do an UHD production. Certainly, I need to select a UHD resource, but also vice versa. When I do a an SD production, best to select an SD resource only and not a UHD resource, because that wouldn't be that efficient. Resources need to support capacities. That's what you have to have in the database as well. Capacity is often network capacity, but also think about licensing. More and more devices you can buy and solutions you buy where you also buy licenses. A multi-viewer that supports 4, 8, 16, 32 inputs, that's often a license. You need to track that somewhere. And properties can be anything, maybe a location. When I know that camera is in location A, I cannot book it when I need something in location B. And all together, we build those resource pools with all those properties, availabilities, capabilities, capacities to be able to manage them and book them later on. And again, those resources are either resources that you can later automate, like your infrastructure, or virtual resources like people, rooms, trucks, desks, etc. Another example next to the resource pools, another low-code application is about designing workflows. What are you doing when you manage an event, when you manage, let's say, again, something in the MCR, a contribution link? Instead of starting like from scratch and saying I have a start time, a stop time, and I give it a name, and then I select each and every resource individually, people want to work with workflows, templated way of working. A workflow includes all the resources you need. That can either be individual resources. I always need this encoder, or usually you would work with resource pools. I need a encoder that supports certain things. It has a certain capacity. It has a certain capability. And then a system like data miner here needs to select right before the event starts an encoder that is available and fulfills the requirements. And then workflows is also about connectivity. When you have resources with inputs and outputs, you need to know how you automatically connect those together. If I have my encoder and I need to loop or feed the IP stream into a processing engine and into a video server, this is about the connectivity. And altogether, we call this a workflow. It's really about resources, resource pools, and the connectivity you need. That's typically done by engineering teams. And then you have the operational teams running the jobs. So you need a scheduling application. It's still the same data model underneath. We're using the same data, but it's a completely different view into the data. So when you schedule something, it's about managing that life cycle. Start with entering the mandatory data, my start time, my stop time, what type of event do I run? I can link that event then to a workflow people in engineering have defined. And then up to you again to decide, is it only like a single phase? I enter data, I let then the automation engine confirm if I have sufficient resources and let the automation run, or I might have some more cycles in between, some more states before things really are running. That can be a approval from your manager. Somebody needs to approve that this can be really deployed and is allowed to run. And once everything has been approved, then that engine, the automation engine, kicks in. You need to deploy the infrastructure right before the event starts. You need to configure, connect, but all automated and undeploy at the end. This is done in the background as an operator. You only want to see what's going on currently. You don't have to take care of the automation underneath. And certainly, not everything is fully automated. You still need the ad hoc operations that can be signal routing, parameter control, because not everything you plan up front and you automate can always happen as you have planned it. There will be last minute changes. There will be things you don't know up front. So what we used to do in media, in broadcast since many, many years doesn't go away. Ad hoc operation stays, but again, much more, let's say, data and event driven. When you look into a routing panel, it's not the goal anymore to show all sources, all destinations you can ever route. Only show me those sources, those destinations with the right labels for that event. This is the idea of having an ad hoc routing panel when it's more data driven. Instead of saying, I have an external feed 1 to 10, better give it a proper name because we have that context in the planning system already. It's not only EXT1 and EXT2, it might be camera 1, camera 2, or the camera operator's name in the label for the source. Once more, the idea of those user interfaces to show the right data to the right people at the right time. And when you look into a connection panel like that, that's also important to mention when you click on the connect button in the middle. It's not only like classic single crosspoint setting anymore. Such connect button can be much more nowadays. That can set up an SRT stream, can run any complex automation. What are we doing here underneath? We run a workflow. The workflow you have defined up front. And the workflow can be something simple like an ISO 5 patch command, connect things together, an ISO 5 sender with a receiver, but can be equally complex to run a full SRT contribution feed with multiple redundancies or a satellite downlink underneath. Just a bit of an outlook, but as a summary, what I want to give keys to success, it's not only about technology. You need to have the right technology. This is key. You need to build upon an architecture that allows you to grow, that allows you to become agile, that allows you to become a software company. And it's all about an open architecture, API driven, that allows you to do monitoring, automation, orchestration all together. We talk about APIs here, but when you only look into technology, that's not sufficient. You need to also embrace what we say agile methodologies. This is for us as a vendor. We have changed our approach, the way we work many years back, becoming agile, but at the same time, we need to educate our customers to become agile. It's about training, offering training for them, really putting that mindset in that it's not waterfall driven approaches anymore. We need to become DevOps engineers. We need to be used to work with CI/CD platforms to automate testing. It's very important. It's part of every project we are running to really educate people to embrace those agile methodologies. And last but not least, it's about empowering people. We need to make it as easy as possible for the people to learn this. It's about offering trainings. It's about giving the right access to all APIs, documentation. We also talk a lot about, coming from the ICT world, about collaboration tools, building communities. People want to talk to people. When they are stuck building their own thing, you need to have somebody to call immediately or to fire a question on communities. And all together, really, like right technology, right methodologies, and the right people. I guess only then we have a realistic chance to build that dynamic media factory that really allows us to use principles from ICT and at the same time keep all the existing knowledge, all the existing requirements that we have from the broadcast industry and build that all together. And with that, let me say thank you very much.